The struct feature and concept, which we explored in the previous course sections, is one of the most important concepts in Go. You will use structs very often to group data together. But there are more data structures in Go which also have their place. And in this course section, we will learn about arrays, slices, and maps. And of course, we'll learn when we need those data structures and why we might want to use those instead of structs. And for that, in this course section, we are going to start with diving into lists of data and how we can manage such lists with arrays. We are then going to learn how we can use slices to work with arrays in a more flexible way. And last but not least, we're also going to dive into maps, yet another data structure built into Go, which also has its place and purpose. Now, as in every course section, I got a brand new project. Just created a Go module with the go mod init command. And I want to start with lists of data, with managing lists of data and what I mean with that. And for that, I'll add a lists.go file. And in there, as always, I'll add my main package and then also my main function because we'll still need that. Now, what do I mean when I say lists of data? Well, let's start in a different way. We did learn about that struct, where we maybe have a product, and hence we have our struct, and in there we then have a title for the product, and maybe an ID, and maybe a price, which is a float. That's what we saw before in the course. The struct concept or feature is a very useful feature because it allows you as a developer to group data together. We group a title, an ID, and a price together into one data package. And organizing data like this is super important because very often in your programs you have more complex pieces of data that you want to express. But in a nutshell, a struct is a data grouping mechanism. And we do group different kinds of data into one piece of data. A title, an ID, and a price are very different data pieces that are grouped together into one data piece. That's how you can think about a struct. Now, in some programs, actually, as it turns out in a lot of programs, you don't just need such kinds of data groups, but sometimes you also have similar pieces of data that need to be grouped together. And that might sound very abstract, so let me give you an example. What if we would be building a Go application that's dealing with some data analysis? And therefore, as part of this application, we might get various values. For example, some weather data, maybe some product prices, which we want to analyze. Doesn't matter. We get different pieces of data. Let's say different numbers. Now, they all express the same thing. For example, if we get temperature values, every number might express a temperature in Celsius or Fahrenheit. But we, of course, have different values. Now, if we work with such kind of data, where we have many values that describe the same thing but have different values, then a struct won't help us. We could, of course, create some struct temperature data like that, and in there have the temperature of day 1, which holds, let's say, a float. And then we have day 2, which holds a float. But doing it like this, solving this problem like this, would be very annoying. Because we have to know in advance how many days of data we want to have. And even if we do know that, we have to do a lot of typing to describe all those days, to set up all these day keys. So that's very annoying. It would lead to a lot of code and to code that's quite unreadable. And working with that kind of data would then also be a bit annoying throughout the application. That's why for such cases, where we describe the same thing and we just have different values, we have a different kind of data structure built into Go. And we have this kind of data structure in basically every programming language out there. It's just a name that's different between all those languages. We have a so-called array. In Python, it would be called a list. In JavaScript, it's also called an array. And an array is a data structure that holds values, potentially different values, that kind of describe the same thing. Now let me show you how we create such an array. For that, I'll create a brand new variable that will hold my array, and let's say we want to work with a bunch of prices here. But of course, it's up to you. Here, I'll just go with some prices, and let's say that should in the end be a list of floating point values, so a list of floating point numbers that we want to store in this prices variable. Now, since it's a brand new variable, we'll use the := operator to create it and set a value immediately. And now we can turn this into an array by using a special syntax. We want to have a list of floating point values, as I said, so I'll type float 32 or 64, doesn't matter. And then in front of that, we add square brackets. This is an important piece of syntax that tells Go that we don't want to create a single floating point value that should be stored in prices, but instead a list of floating point numbers. Now, between those square brackets, we then have to tell Go how many values we want to store, and let's say that's 4. So we want to store 4 floating point values in a list of floating point values inside of prices. Now, it's still not all. When using this syntax here and immediately assigning a concrete value to prices, which is what we do with this operator, we also have to let Go know which values should be stored in this array. And for that, we add opening and closing curly braces here. Now here, between those curly braces, we can now enter the values that should be stored in this list. So something like 10.99, 9.99, 40, 5.99, and let's say 20.00, or just .0. This now creates an array, a list of 4 numbers, 4 floats that's stored in prices. And you can create arrays based on any kinds of values, not just floats. You can create an array of strings, of integers, even arrays of structs and other arrays, so-called nested arrays, are possible. But let's start simple. Let's take a look at what we created here by using the format package and calling the println function, to which I then pass prices. And now we're not using this struct anywhere, so therefore I'll get rid of that since it was only there for demo purposes anyways. Now with that array created, if we open that terminal here, if we run our module, we get that list of data output here. And that's how we can create such a list of data. And the key difference compared to a struct really is that all these values describe the same thing, a price. But of course we describe different prices, and hence we have a list of these different values that describe the same thing. And that's a fundamentally different idea than we had it with a struct. And different scenarios and use cases in your code simply require different solutions. Now let's take a closer look at this array thing and what we can do with it and how we can create it. Because here we only see one way of creating an array. We can also create an array by using the var keyword and then giving the variable any name of our choice. Let's say we have a couple of product names, so I'll choose product names here. And now I don't want to initialize it immediately, I just want to declare this variable and make it clear that it should contain an array as a value. So it's not a string, which would be a single value, but instead an array of strings. Same syntax as down there. Square brackets in front of the type of value that should be stored in that array. Now, when creating such an array, you also typically want to set a length for that array so that it's not an empty array which has no items at all. And you do that by adding that length, so the number of items that should be stored in that array, between the square brackets. So we could use 4 again, or 3. It really depends on how many items we want to store. Let's go with 4 here. With that, I'm creating this array, and if we now print that without assigning any values, if I print my product names like that, and we then open that terminal again, if we run our code, we see this. It's very important to note that the program doesn't crash or anything like that. Instead, the null value that's now set for product names is now simply an array with 4 empty slots. And that's what this in the end represents. Now, of course, we could set product names equal to an array now by, again, let's say, creating an array like that. And then we could pick different names like a book and so on. And you also don't have to set all the names. If I just set one name and I run this program again, you see one name is set and the other slots are still left empty, so that's possible. But you also sometimes have the scenario that you want to set specific values. Let's say the second value in an array. Or you want to read a specific value instead of outputting the entire array. And therefore, that's another key mechanism that you need to know as a Go developer. How you can target individual values in an array so that you don't always have to set or read the entire array as we're currently doing it. Now, for that, first of all, to get rid of those yellow squiggly lines, I'll merge this into one line here, like that. And then I want to show you that syntax for accessing individual items. Let's say we want to print the third price in the prices array. So here I want to print prices, but not the entire list, but just the third value. For that, we got a special notation that allows us to access a specific value in an array. We again use square brackets, but now not to create a new array, but instead after a variable name that holds an array to tell Go which specific item we want to access. For a struct, we used the dot notation, but for arrays, that's not available because arrays are not structs. Instead, for arrays, we use square brackets, and now we also don't have key names for those different values. I mean, where would those key names be? But instead, all those values have unique index values, which are automatically assigned. And the logic here is very simple. The index values always start at 0 for the first element. And that can be a gotcha. It's not 1 for the first element, but 0. So if you want to output the first element, you would write prices and then 0 between square brackets. So if you want to output the third element, we need which value here? 2, because we have 0, 1, 2. This has an index of 2. So that's how we get access to the third element. And that's just something to keep in mind. Thankfully, it's the same in most other programming languages that arrays or lists, or however that feature might be called there, start at index 0. So with that, if we save this and open our terminal, if we now run this program again, we see that 45.99 is being output. And that is how we can create arrays and how we can read single values from arrays. We can, of course, now also set single values. For example, if you want to set, let's say, the third product name, we did set the first one thus far. The other slots are left out empty. If we want to set the third one, we can set product names and then again target the third element, which still has an index of 2, and set this to a specific value, like a carpet. Now on product names, we'll have the first value being set and the third value being set, and the second and fourth values will still be empty. But that's fine, that is something you can do. With that in place, if we run this program again, we output a book, then our empty blank slot, then a carpet, and then another blank slot in this array. That's how that works, and that's how you can work with arrays. But that's far from everything that you need to know about arrays and that you can do with arrays. Arrays are extremely important and useful, and that's why we have more features related to arrays that also are important to understand. Specifically, we have the slice feature. That's a key feature of Go and a feature you'll use a lot. Now, what's a slice? Here we have two arrays, product names and prices. Now, thus far, we learned how we can work with the full array, for example, to output the entire array, or how we can target individual values, like we do it here. Sometimes you also need a subset of an array, so a part of that array, more than one value, but not the entire array. And that's where a slice comes in. Down there, I want to create a slice of my prices. Let's say we want to fetch these two prices, $9.99 and $45.99. So we want to create kind of a new array based on this array that omits the first and last values. That's what a slice can do for us. So let's say our featured prices should be that slice. So that's a brand new variable, which I'll therefore create with the colon equals an operator. And we now can create a slice, so create the value for featured prices based on this prices array by referring to that prices array, and then again using that square bracket notation. But now instead of targeting a single value, like the second or third value, we can now also use a slightly different notation. We can type 1:3. And that creates a slice from that target array, which means we'll take a look at that array, and then we'll start at the element with index 1, which as we learned is the second element. And then we take all the elements up to the element with index 3, excluding that element though. So the first value is always included, the second value is excluded. So this notation would start at the element with index 1, and then would go all the way up to the element with index 3, which in this case is 20. That will have an index 3 since it's the fourth item, but will not include that item but exclude it. So that will create a brand new array, though it's technically called a slice, that will only contain these two values in the middle. So if we now again output that, if we print line featured prices, if we run this program, we see this slice being output here. And of course, that is just that middle part of our original array. And slices therefore are another core feature, since in a lot of applications you do need to work with parts of lists. And slices allow you to easily create brand new lists based on other lists of data. Now, slices are extremely useful and versatile, and there is way more you can do with slices, and you should know about slices. For example, regarding that syntax here. We learned that we can start at some index and end at some index, excluding the value at that index. But you can, for example, also omit the starting index and just write colon and then the end index. If we do this and we run our program, then you'll see that what we get is this kind of list. So it's almost the entire original array, just the last value, the 20, is missing. And the reason for that is that this notation tells Go to start at the beginning of the array or slice which we are targeting, and then go all the way up to some element with some index. You can also do the opposite and maybe start at the element with index 1, so not the first element, but the second element as we learned, and then go all the way to the end of the array or slice which we are targeting. If we would run this code here, we get the end of that original array. We get this part here. So these are things we can do. What you can't do here, and what you can do in some other programming languages, is use negative indexes. So you can't start at the last element with a minus or something like that. That works in some other programming languages. It doesn't work here. What you also can't do is pick a higher end index than the original array has. We already get an error here that it's out of bounds. So the highest value you can select here really is the end index plus 1. Plus 1 because the last element by default is excluded. So to give you a way of targeting that last element as well, Go allows you to pick the index of the last element, which would be 3. The last element here has an index of 3, and add 1 to it. That's the highest bound. Now we got started with slices and arrays. Time for a brief look behind the scenes to fully understand the connection between slices and arrays. Slices are like a reference, like a window into an array, a bit like a pointer, though it's a different concept. When we create an array like prices, that array is stored in memory. When we then create a slice based on that array, we get a window into that array, so to say. And therefore, if we would modify an element in a slice, we would also modify the same element in the original array. So for example here, if I use my featured prices slice, which again is this part of the original array, and I added the first item of that slice, which is $9.99, because we start at the second element here when we select that slice, which is $9.99, so the first element of that slice then is that $9.99 value. If I added this and set it to 199.99, then indeed what you'll see is that when we output the prices array, so the original array, which I did not directly edit here, we will still see that $9.99 will have been overwritten by 199.99. So if I run this program, indeed we see that the original array has its second value overwritten by this value, because a slice is just that window into the original array. And that also has one important implication. When you create a slice, you don't copy the original array. So you don't have that copy in memory that occupies extra memory space. Instead, you still only have one array in memory, and your slice is just a tiny reference to a part of that array. And hence, it's a very memory efficient way of selecting parts of arrays, and if you want to do that, of editing parts of an array. Now, Go also saves some metadata for our slices that can be useful to look into. For every slice, we got a length and a capacity. And we can output both here to understand what it is. I'll start with the length. The length of featured prices can be output by using the built-in len function, which is built into Go just like that. You don't need to import any package for that. It's a default Go function. You can also call it on other value types, as you see here in the tooltip, for example on arrays and also on strings, but here we'll just call it on the featured prices slice. And then I want to output a second value, which we get by calling the built-in cap function, which just like len is built into Go. To cap, I'll also pass my featured prices, and that will give us the capacity. Now here, if I run my code, we'll get the same value twice, will get free twice for both the length and the capacity. But what are these two values? The length gives us the number of items in a slice or array. So if that slice, featured prices, has 3 elements, which it does, length will give us 3 as a value. The capacity is a bit more complex. It's the same value here, but that would be different if we would output highlighted prices. If we output the length and capacity of highlighted prices, then we'll see a difference. So if we use that other slice we got here. Here, if we output that, we get 1 and 3 as values. Now, why is that? Highlighted prices is based on featured prices, which in turn is based on the prices array. So they share the same array under the hood. But highlighted prices selects everything from the start of featured prices up to the second element of featured prices, excluding that element. That's why we have a length of 1. There is only one element which is part of that highlighted prices slice. But we have a higher capacity because the slice, and therefore the original array on which highlighted prices is based, actually has more items left. In featured prices, where we selected everything from the second item until the end of the original array, we still have this entire subset left. So if in highlighted prices we then select just the first item, we could theoretically still select the other 2 items, and that's why we overall have a capacity of 3. Why not a capacity of 4, since the original array has a length of 4? Well, because, and that's important to understand about slices, you can always select more towards the end of an array, but not towards the start, so towards the left. Since the first slice on which we are based starts at the second element and not at the first element, any other slices based on it can't go further to the left. So we can't go back to that first element which we omit here. That's why the capacity only counts towards the end of the original array, but omits any elements that might have been filtered out before. Can be a bit complex to wrap your head around, but is something you can simply play around with in code as well to get a feeling for it. In the end, it's just important to understand that you can always select more items to the right, but never to the left. And to show you what this means, I'll change highlighted prices. Here, after outputting all of that, I'll use highlighted prices, which is based on featured prices, and I'll set it equal to highlighted prices, so not featured prices, but highlighted prices, and then select everything. Select a specific index, like 3 here. And now, if I repeat this code here, without outputting prices again though, you will see that if you now run this code again, you get that entire featured prices slice. And now the length matches the capacity. Now that is a quite interesting behavior because I did now reslice highlighted prices based on the previous highlighted prices slice. It might have been clear that this works if I would have used featured prices here, but I did not do that. I used highlighted prices here. And highlighted prices before in this code block was just one value, because we sliced it to be only up to the second value. That's what I meant with you can always select more towards the end of an array or slice. Even though highlighted prices originally only had one element, we can reslice based on that one element slice and now suddenly select more than that one element because internally Go always memorized that there is more content available to the right of the selected slice. And that's what this capacity here kind of told us, where we had a difference between capacity and length. There were more elements available and Go memorized that. That's why on this one element slice, we still are able to reslice to pick up more elements, but only to the right, not to the left. There is no way of getting access to this original first value in that prices array. That's gone forever since we started by creating a slice that omitted that value. And that's a lot of deep dive theoretical stuff. I'm fully aware of that. These are just some gotchas and interesting quirks for that slices feature that you should at least have heard about. Because sometimes when you write your own code or you dive into other Go projects, you might suddenly see code snippets like this, where we suddenly select more than was previously stored in a slice, and you might wonder why that works. Well, it works because if you select more to the end of an array, you can't always do that because Go memorizes that original array. But as a special quirk, it kind of only does that for more values to the right of the existing slice, not to the left. So that was a lot of deep dive stuff on slices, and you won't need all of that all the time, but as I mentioned, you should have at least heard about it. Now, slices are not just a useful feature because you can make other people dizzy by diving into slices on slices and stuff like that, but also because with slices you can create dynamic arrays. Because let's come back to that original prices array. One downside of using that array was that we had to define ahead of time how many values we'll have in there. Now, sometimes in the applications you're going to write, you know exactly how many values you'll have in a list of values. For example, if you handle some user input in a form that has exactly 3 form fields, you might have an easy time storing those 3 values in an array because you know ahead of time that you'll get 3 values. But let's say you're loading a list of prices from a database, and the data in that database changes frequently. Then when you write your code, you don't know ahead of time whether you'll need 4 or 5 or 100 prices. So having to set the length of an array in advance in your code can be a restriction that's quite annoying. In other programming languages like JavaScript, you don't have that restriction. There you can create an array and it's automatically dynamic. So you can always add and remove elements just as you want to. For Go arrays, that's not the case. Prices is an array with 4 elements and you can't just add a 5th element, even if you wanted to do that. Now, since we have that restriction, Go thankfully also has a solution for us, and that solution again is that slices feature. Now I'll comment out this main function because I want to keep it here for reference, but I don't want to execute it anymore. Instead, I'll write a brand new main function so that we have an empty, cleaned up main function to dive into that slices for dynamic arrays feature. Let's say we again have some prices, but this time it should be a dynamic array where we can add more values whenever we need to. You can create such a dynamic slice with a syntax that's similar to what we saw before, so square bracket float 64 curly braces, but you may now also omit the length here. If you don't specify the number of items that should be stored in this array between those square brackets, Go will actually automatically create a slice for you, and since a slice always is based on an array, it will also create an array for you behind the scenes, but it will automatically ditch that array and create a new array if your slice grows beyond the bounds of that behind the scenes stored array. But we'll see that in a second. So here we can create an empty slice like this, or maybe even populate it with some starting values. Both is possible. Now we can still work with that as before. We can build slices based on this slice. We can select individual elements. So for example here, I can print prices 1. And if we run that code, unsurprisingly, hopefully, we see 8.99. Now we can also select a slice here if we want to, like this. And if we execute that, we see 10.99. So that's still possible. That all works. Now we can, of course, also assign values like this to override the second value. But what we can't do is assign values to indexes that are not part of the slice. If we would try to do that and we then output prices thereafter, it crashes because the index is out of range. I don't get this error in the IDE, but I get it when I try to execute that code. So we still can't access indexes that don't exist. But I told you that this would be dynamic, right? But not like this. Instead, there now is a built-in function in Go, the append function, which you can execute like that, which, as you see here in the tooltip, wants a slice as a first value, and then a list of elements that should be added to that slice. So here we could refer to prices, which is a slice, as I mentioned. This syntax creates a slice, and Go creates the array that belongs to the slice behind the scenes. And now we can, for example, add 5.99. And that will now append a new item, but it will actually also return a brand new slice. So it actually does not edit the original slice, but instead what append does is it tells Go that we want to add an item to that slice, and therefore also to the underlying array. Now, of course, an array has a fixed length. So what Go will do in this case is it will create a brand new array and add that element to that brand new array, which is created such that it has the capacity for that new array. So here I got my updated prices, and I can now print my updated prices here if I want to. With that, if we now run this program, we see that we got our updated prices here, which is the original prices, slice, and therefore array, plus the 5.99. Now, if I would print prices here as well as updated prices, so if I print the original slice and this new slice, you see that the original slice did not change. This is still just these two values, just 9.99 instead of 8.99 because we overwrite this here. But the original slice and array was not changed by Go. If you wanted to do that, you would have to instead reassign this appended slice to the existing prices slice instead of creating a new variable. Then, of course, if you do this and you output this prices slice, then you'll see that it changed. And again, Go will manage the arrays for you behind the scenes. And if you reassign an appended slice to an existing slice, it will of course also ditch that original array, which only had 2 elements before, and use that brand new array that holds that extra third element for that slice instead. So memory management is taken care of by Go here. And since we now have that extra flexibility where we can always add new elements if we need to, it's way more common to work with slices right from the start in Go than it is to use arrays. You can still use fixed length arrays if you know for sure that you will never have more than X amounts of elements in a list. But if there is at least a slight chance that you might want to add new elements as your program executes, you should definitely go for this slices approach right from the start instead. Because that allows you to add elements to slices and to let your arrays grow just as they need to. Now, in case you're wondering whether there also is a function to remove elements from a slice, since there is an append function, well, yes, kind of. We can, of course, just create a new slice that removes the element we want to remove. If we want to remove the first element, we simply create a new slice based on the existing slice that starts at the second element and selects everything up to the end. That gives us a brand new slice that omits that first element. So with that, we of course did remove that first element, which was 1099. So that works like this. There is no function for doing that since we already have the built-in mechanism with that feature that allows us to build slices, this slicing syntax here. Working with arrays and slices is actually not that difficult, but we did learn a bunch of very important concepts over the last minutes. And hence it's time to practice what we learned. Attached you find this practice.go file, which contains a pretty empty, Go code file, just with the main function and main package, but which also contains a lot of instructions that allow you to practice what you learned. And as always, you can then go through my solution lecture to compare your solution to mine and see how I solved this. Now, in this exercise here, I want you to start by creating a new array, very important, an array, not a slice, that contains 3 hobbies that you have, any hobbies of your choice. So create such an array with an appropriate length and value types being stored in there, and then output that array in the command line. In task number 2, you should also output print the first element and just that element, and then also the second and third element combined as a new list. So you should also output these pieces of information. In task number 3, I then want you to create a slice based on the first element of that array that contains the first and second elements. So start at that first element, but make sure you also contain the second element. Now, very important, I want you to create that slice in 2 different ways. So in the end, you should create 2 slices, though you can comment out one of the 2 approaches so that you're left with 1 new slice in the end. But create it in 2 different ways because there are different ways of selecting the start or the first element of an array and so on. So find 2 ways of creating a slice based on that first array here that contains the first and second elements. Also output that new slice once you're done. In task number 4, I then want you to reslice that slice from task number 3 and change it such that it contains the second and last element of the original array. So don't create a slice based on the original array itself, but create a new slice on that existing slice which you got from task number 3, but change it such that it's the second and last element instead of the first and the second element which it was before. And then also print that updated slice. Now in task number 5, you should create a brand new array, but a dynamic array, and therefore it's maybe not really an array. You learned what you'll need. And that should be a dynamic array that contains your goals that you have for this course, and you should at least add 2 goals into that dynamic array right from the start. Also output that array thereafter then. In task number 6, I want you to overwrite the second goal in that array which you created in task number 5 and set it to a different goal, and also add a brand new third goal to that dynamic array. So that's what you should do in task number 6, and then output that updated dynamic array. And then I got a bonus task for you. A bonus because you'll need to do something which we haven't done before. I want you to create a product struct, that is something we did before, which has a title ID and price. And then you should use this struct to create a dynamic array, a dynamic list of such products, at least 2 products. And then I want you to add a third product to this existing list of products. Again, that is something we haven't done before, so maybe you find a way of achieving this. Otherwise, I'll show you how that works in my solution. So, did you succeed? Let's now solve these tasks together. And let's of course start with task number 1. In task number 1, we want to create a new array that contains 3 hobbies. So I'll create that array, and we get various ways of doing that with the var keyword and this slightly more longer syntax, or we use the very concise syntax where I create a hobbies variable and we use the := operator to then create that array. Now here for task number 1, we need a real array. No slice, but a real array, as I highlight here, and therefore we wanna define the length of that array. So the number of items that will be stored in it in advance. We also need to define the value type in advance. That's the case both for dynamic arrays, slices, and real arrays. And here, since I want to store some hobbies, so some text in the end, string sounds like a fitting name. And then you learned we need the square brackets in front of that. And since we'll have 3 hobbies, I'll add a 3 here. And then curly braces like that. Now we can set our different hobbies by accessing the different indexes and setting it like this. Or we set it all in one go and have something like sports, cooking, and reading as hobbies here maybe. And then of course we don't need a deadline unless we want to overwrite the first element. Now we created that array and we want to output that array, so with help of the format package and the printline function, we can now print hobbies. And that should be task number 1. Now to see it in action, I'll run this module, and for that I actually need to init my module first of all, which I haven't done before, so let me quickly do that with some dummy identifier, and then I can run this module. So now we see sports, cooking, and reading here. This is working. In task number 2, we now want to output more data from that array. The first element standalone, and then the second and third element combined as a new list. So for that here, task number 2 involves some printing. But now I want to access the first element. And you saw the syntax a couple of seconds ago actually. We can access specific elements in an array to read or set them by using square brackets after the variable name that contains the array. And then we use the index of the element that we want to read or write to. Now the index, that's the important thing, starts at 0. So if we want to read the first element, we don't use 1, but we use 0 instead. And this will now output the first element. Now that's not all though, we should also output the second and third element combined, and for that we'll need a slice, because we learned that with a slice we can select a subset of an array and then work with that. So if you want to select the second and third element, then we want to start at the element with index 1, which is the second element, and then select everything up to another index. That index will be excluded though. So if I would write 1:2, we would not select the second and third element, which you might think, since we have the indexes 1 for the second and the index 2 for the third elements. But instead, since that element will be excluded, we would just select the first element. Instead, we need 3 here, so the index of the last element plus 1 to select that last element and include it in that slice. Or we use the shortcut and just type 1:nothing to select everything up until the end of that array. Now here I'll go for the more explicit syntax, but either of the two approaches is fine. And with that, just to quickly check that, if we run this, we now see sports, which is that first element for line 11, and then cooking and reading, which are the last 2 elements, so the second and third element for this line of code here. So that's also working. In task number 3, we should now create a slice, another slice, based on the first element, so based on that first array actually that we have here, that contains the first and second elements. instead of the second and third elements, which we have here. So in task number 3, I'll add a brand new slice and now also store it in a variable. And I'll name it first hobbies, or main hobbies maybe. Create a brand new variable, and then use my hobbies array and create a new slice. Now to select the first and second elements, I want to start at the index 0 and then select everything up to index 2, since that will select everything up to the element with index 2, which is the third element, which is then excluded, so it will select the first and second element successfully. Alternatively, here we omit the 0 to start at the beginning of that array on which this slice is based, and then just go up to the third element and exclude that element. Either way, we'll select the first and second element, and with that I also show you 2 approaches of making that selection. And then we also want to print that so that we don't get an error, and print main hobbies here. And now if I zoom out a bit so that we have more code on the screen, if I run this code again, we do get sports and cooking here, which indeed are my first 2 elements. So that is also working just as it should. Now, task number 4 wants us to reslice 3 and change it such that we contain the second and last element now, instead of the first and the second element. Now that works because behind the scenes, a slice actually just points at a part of an array, and we can always select more from that array as long as we expand our selection towards the end of the array. Towards the beginning, that's not possible. And as a in-between step, we can actually again print the capacity with the cap function of main hobbies. And what we'll see when I do that, and I run this code, is that that capacity is free even though main hobbies only contains 2 elements. It's free because the array on which it's based actually has 1 extra element after that last element that we select here when we build that slice. And again, as I mentioned, extending the selection towards the end after we already have a slice is always possible. So we can reassign a value to main hobbies. Hence, I'm not creating a new variable here. I'm using an existing one. And I actually reassign based on my existing main hobbies slice. And we want to create a slice that gives us the second and last element. Now we are basing this new slice on the existing slice. The existing slice contains the first and second element. But because we have that link to the behind the scenes array, and extending towards the end is always possible, we can also expand this slice to get the last element of the existing array. Now I'm not interested in the first element anymore, and therefore I'll start at index 1 to omit that first element, which was still part of that slice before, because we included the first element here when we originally created that slice. Now I want to go all the way to the end, and you could therefore think that you can just use this shortcut, but that would actually not work. If you save it like this and you then actually print main hobbies like that, if you give this code a try, you'll see that it actually just outputs cooking. So the last element, reading, is not included. The reason for this is that I'm building my new main hobbies slice on the existing slice. And the existing slice does not include the last element here because we only selected up to the last element. So only the first 2 elements. But I mentioned that expanding would be possible, and it is, but if you do expand a slice in the process of reslicing, then you explicitly need to specify the end index. If you leave it open like this, it will use the last value from the existing slice instead. If on the other hand I set this to free, as we did it here in line 12 as well, then we explicitly tell Go that we want to go to the underlying array and give us the element prior to index free, which is this element which has index 2, and include that in the slice. Can be a bit of a gotcha, but this is how we can now extend our selection here. With this, if we now run this code, we got cooking and reading included. So the second and third element with that reslicing approach. Now in task number 5, we now want to leave that array we worked on thus far and instead create a brand new array that has one special trait. It should be dynamic. So we should be able to add new values to it. And therefore, here I'll add my solution for task number 5. And since it's an array that will contain a bunch of course goals, I will name it course goals. That's my variable name. And to create a dynamic array, we need to create a slice right from the start and let Go create the underlying array behind the scenes for us. The syntax for that is very similar to what we had up there. The only difference is that we don't specify a length ahead of time. The syntax we need here is that we still want to store strings because our goals are still pieces of text. And we still need the square brackets, but we don't give this a fixed length. Instead, we leave the square brackets empty and then add our curly braces to either create this as an empty slice at the beginning or to already store a couple of values. And since we should create at least 2 goals here, I'll start by setting 2 goals, which are learn Go and learn all the basics, something like that. These are my course goals. And that's already task number 5. Now we can also print this to see whether that worked, and hence print course goals. Go run this, and we see our course goals here. So that is working. In task number 6, we now want to change that dynamic array, and we want to set the second goal to a different one and also add a brand new third goal. Now let's start by setting that second goal. For this in task number 6, I'll first of all access the second goal in course goals by its index with this square bracket notation, and the index here is 1 for the second goal, and we can change this to learn all the details. Something like that. Now we should also add a brand new third goal, and for this we can set course goals equal to the result of calling append. And append, as you learned, is a built-in function that operates on slices and allows us to add brand new values to slices. And here I want to append 2 course goals and append a brand new third goal, which is learn all the basics again, maybe. So we overrode learn all the basics with learn all the details, and then we add learn all the basics again as a third element. And now with that, if we print our course goals here after changing those goals, if we run that code, indeed we now see we have learn Go, then as a second goal, learn all the details, since we changed that here, and then as a brand new third goal, learn all the basics. And as explained, behind the scenes, Go did create a brand new array for us, basically ditch the old one, and bind this slice to that new array. That all happens behind the scenes for us. We don't have to worry about it. Now in task number 7, I now got a bonus task here that involves a struct. A product struct. And therefore, we first of all need to define this struct. So maybe here, right at the beginning of the file, I'll define my product struct as we learned it, give it an ID, which is maybe a string, a title, which might be a string, and then a price, which could be a float. And that's what we did before in the course already. Now we got the product struct. Now I want to create a dynamic array based on that struct. I want to create a dynamic list of products that contains at least 2 products right from the start. And then we want to add a third product to that existing list of products. That might sound overwhelming, but thankfully it's actually not difficult. Here for task number 7, I'll add my products variable, And here I want to contain a dynamic array. So we need a slice. So we need empty square brackets. Then the data type is not string or float or int, but it's product. And I mentioned this before already. You can create arrays that contain structs or even other arrays. You are not limited to the primitive value types of numbers and strings. Storing structs in arrays is absolutely fine, and that's what we'll do here. So this syntax now creates a slice, a dynamic array that contains products. And we can now initialize it with some product data by using the struct literal notation here to add brand new products with an ID of first product maybe, keeping the order defined here when I set up the struct. Alternatively, we can assign values by using the keys again, but here I'll just keep the order, add a comma, and add a first product as a name here, as a title, and then as a price $12.99. Since this can get a bit tricky to read here, we are also allowed to split this across multiple lines as long as we add a comma here at the end, and then even split the struct creation into multiple lines, and also add a comma here in line 44. And now if I reformat this, this is more readable. Now that's one product. We can now copy that and add a second one. So the second product, where I say a second product, and this has a price of $129.99. And that's now my products list, my dynamic list full of product struct instances. Of course, we could have also created those instances in variables ahead of time and then just added those variables into that list, or we do it like we do it here, all in one go, just in time. Either way is fine. And now, of course, we can again print our products like that. Now, when I save that, you'll note that I have some yellow squiggly lines here that tell me that I have some redundant type here. Now, it turns out, and that is something you can't know, but it turns out that when you create such struct literals inside of such an array, which already is defined to only contain these kinds of structs, you can omit the struct name here and just create the structs like that. Since Go already knows with certainty that this list will only contain products, because you clearly define it here. So then you don't need to repeat that type name here when you create the struct instances, even though you are allowed to do it. But it's redundant, so you can shorten the code to look like this. And now with that, we're creating that list of products, we're outputting it, and hence if I run that code, we see our product list down there. Now, since it's a slice here, and hence a dynamic array in the end, we can also solve this last part of the bonus task where we should add a brand new third product. And for this, we could create the product just in time, or actually create a new variable that contains it. This is up to you, where I create my product with that struct literal notation. Now we need the struct name again, because here it's not clear that we'll have a product struct in this variable, because we're just creating the variable. And then here I'll give this an ID of third product as a name, and give this a price of $15.99 maybe. Don't forget the comma at the end here to be allowed to structure it across multiple lines. And then we can append this new product and change our product's variable to be equal to the result of calling append on products, where we do append this new product now. And then if we want to, we can also again print this updated products array. With that, if you save everything and you run this, you now find that updated list down there, which contains that third product. And that's now also the bonus task solved. Maybe you also were able to come up with that. Maybe not with that shorter syntax here, but with the rest of this task. And if you did, great. If you didn't, no problem at all. We haven't seen this before, and now you did see it. You now also know that you can store structs in arrays and how that works in detail. Now, before we dive into maps, which is another interesting kind of data structure, there is one special syntax which I want to show you, which is especially interesting when you work with arrays and slices. Specifically also when you work with append. Append actually does not just take one value that is appended, instead you can append as many values as you want. So here we could also add a couple of other values here, as many as we want. There is no limit at all. So it's really up to you. Now that's good to know, but the key syntax that I want to show you is indirectly related to that. Sometimes you have an existing slice and you want to append another slice or array to it. Let's say here we have our discount prices, and that's a brand new list which I create here, a brand new slice, let's say, which I'll copy from up there, which contains totally different prices. Something like that. Now we might want to merge discount prices into this prices slice. Of course, here it's just an example, but it is highly realistic that you will have some applications that need to merge different lists. For example, existing users with a list of brand new users that signed up during the day. And you can use the append function to perform such merges as well. Now, for that we can reassign prices and call append again. And now you could think that you just append discount prices like that. But if you try that, you get an error. And the reason for that is that you now try to add a slice, so a list of floats, in a place where a single float is allowed. Because prices is a list of floats, not a list of lists of floats. And discount prices is a list of floats. So adding the full list as one item into that existing list is not valid. Instead, we have to kind of pull out the existing items. And there is a special operator in Go which you can use for that. You can add 3 dots here after discount prices, exactly 3 dots, to instruct Go to go to this list and take out all the elements in that list, so these 3 prices, and add them as separated, comma separated elements to this append function, so to say. So that is an important syntax that allows you to pull out all the elements of a list and use them as separate elements in a place where separate elements are needed, like here for append. We can add as many values as we want, but they need to be separate elements. And that's what we create here with this operator. And therefore now if we print our updated prices thereafter, after using this special operator, if we run our code file here, you see it's a long list of prices and it includes these prices here at the end. Now we had a very thorough look at arrays and slices. For the moment we're done with that, and I will change the main package here in lists go to lists instead, so that go run dot no longer executes that, and I'm fine with those yellow squiggly lines here, because now I'll add a maps go file where we will have a look at another key data structure available in Go. And I'll turn this into my main package and give that main function. And therefore actually I'll move the lists go file into a lists folder so that we don't have a clash here with multiple top level files using different packages, which is something Go would not like. In a subfolder, using a different package is fine, as you learned before in the course. So now we get this maps Go file, and in here I want to dive into maps. So what are maps in Go? A map is a different kind of data structure which you can also use to group data together. It's a bit like a struct, but different. Now let me show you how a map looks like before we then explore how it's different from a struct. Let's say we want to store a bunch of website URLs here. So we have different companies and those companies have websites. For this, we could add a websites variable. And of course, now we could create an array or a slice. So maybe a slice of websites where we have something like google.com and then also something like AWS.com for the Amazon Web Services. And then maybe a bunch of other URLs as well. This works, but saving those URLs like this could have a couple of disadvantages. For one, if someone looks at this code, or if we ever want to output this code somewhere, we just see the URLs. For some companies like google.com, it's clear to which company this URL belongs. But to understand that AWS belongs to the Amazon Web Services, it's important that you heard about that company and its abbreviation before, otherwise this doesn't tell you anything. So having an extra label here could make a lot of sense. Now, in addition to that, if you want to retrieve a URL, let's say you want to find Google's URL, you always need to memorize that Google is the first URL here so that you can retrieve it by index. Possible, but if you have a long list of URLs, this can get very cumbersome if you need to start counting those different URLs to find the right index. That's a problem a map can solve for us. We can create a map by using the special map keyword in Go. And then we have a special syntax here where we need to tell Go which kind of map it is. Because a map, like a struct, is a storage where you have values of a certain type and then keys that identify those values. So labels for those values. You have key value pairs, that's a map, just like a struct. I'll talk about the differences to a struct a little bit later. And since we have these two parts, key and value, we now need to define two parts when we tell Go how our map should look like. Because both the key and the value stored under a certain key can be of various value types. That's why we first of all add square brackets here, and between those square brackets, we let Go know which type of value will be used for our key. Very often that will be a string, but it could be anything. You could use some struct type there, so a pre-created or custom-built struct, or an integer, whichever key makes sense to you. Now here I'll start with a string. And then directly after the square brackets, without any blank or anything like that, you now set the value type. So the data type used for the values stored under certain keys. And here that will again be a string, because my URLs, which I want to store, will be strings. So in this case, both the keys and the values will be of type string, but that's not a must-have. You can have different types, and you can use all kinds of types for the key, and you can use all kinds of types for the value. Now, again, without a blank, you can add curly braces here. And this now finishes the creation of a map, though you can also initialize it with some default key value pairs, but you don't have to. You can also create an empty map, which is what this would do. But you can now also set some key value pairs, typically in a new line for better readability. And now here, since I made it clear that my keys will be strings, we need double quotes here to create such a key string. And that could be Google. And then you add a colon, just as you do it in structs, and you set the value for that key, which in this case could be https google.com. And then, separated by a comma, I can also add Amazon Web Services and then set my URL here, like that. And add a comma to make it clear that this is part of that overall map, and we have a line break thereafter. And this is now a map with two default key value pairs. Now we can, of course, as always, use the format package to print that map and see what that gives us if we print websites. By the way, as soon as you save, this code gets auto-formatted, and Go ensures that this is lined up such that it's a bit easier to read. Now, if you run that code, you will see that this map is being printed here in one line, but it is this map. Now we do have this map. Now we can, of course, also work with that map. For example, it would be very common that we want to extract one specific URL. And that's why we are using a map in the first place, because now we don't have to memorize its position and use the index, but instead we can extract a value by key. So here, if I want to print the URL of Amazon Web Services, then we access websites. And now again, just as with arrays and slices, we use square brackets. But now between those square brackets, we don't have the ID, but instead the key. So here now I can access Amazon Web Services. Of course, you need to make sure that you don't introduce a typo here, because otherwise, if I just type Amazon Web Service, for example, without the S at the end, we would target a totally different key, which simply doesn't exist here. So you must avoid such typos. But with that, again, if I run this, we can extract that URL here. And that's the advantage of maps. We can use specific labels, keys, to extract our values by such keys, and in some scenarios, that is simply easier to memorize than the position and the index of an element. Now, when you work with maps, you are also not stuck to the initial map. You can always add new key value pairs. So unlike with arrays, there is no difference between arrays and slices. A map is a map and it's always dynamic. You can always add new key value pairs. So if you want to add a new website, you just access websites, and then you access a key that doesn't exist yet. For example, here I could access LinkedIn, which is a key that's not part of the original map, and just assign some value here, like linkedin.com. And if we then print our website's map thereafter, if we do this, and we save all that code, and we run our code, then you see that here LinkedIn is part of that map. So adding new items is always possible and super easy. You just target a key that doesn't exist yet and add that value that you want to add. Of course, you can always overwrite a value by targeting an existing key and setting a new value for that key. Sometimes you also want to get rid of keys, and you can do that with the built-in delete function, which is built into Go, just like append was built in, and delete once a map and then the key that should be deleted. So here the map which I want to target is websites, and then the second parameter is the key which I want to delete, and let's say that's Google. So this first key here, and if we target that with this and I then print websites thereafter, you will see that if you save everything and you then run this code here, this new map here only has Amazon Web Services and LinkedIn, but not Google, because we deleted Google. So adding items, deleting items, overwriting items, and reading items, that's all relatively straightforward with maps. Now the big question that you might have is, why maps? We already have structs, which are already key value data storages. Well, there are two main, very important differences. The first important difference is that for maps, you can use anything as a key. Here we are using strings, but you could also create a map that uses integers or even some array or a struct as a key. So any value can be used as a key. And that gives you more flexibility since you're not stuck to just using human readable text as keys, even though that is probably what you'll do very often. But you have more flexibility there. Another key difference is simply that maps solve a different problem. With structs, you have predefined data structures. For example, if I come back to that product struct, which we saw before, then we make it clear that we have an ID, a title, and a price. And that's then our product. Now, once we defined that struct, when we work with it in our code, we can't just add a new key value pair. Instead, this is set in stone, so to say. We also can't delete a key value pair from it. So these things which we can do with maps are not possible for structs. And that's not a disadvantage, instead a struct solves a different problem. It's great whenever you have clearly defined kinds of data that should have exactly this shape. Whenever you instead have a collection of values where you want to have custom labels to identify those values, a map is your choice instead. Like here for the URLs. This could be a super long collection of URLs for tons of companies, and we can expand it and shrink it just as we want with a map. It's a bit like an array. We have the same kinds of values, URLs, but we just don't want to have indexes, but instead custom labels. And that's why we use a map instead of an array. With a struct, we wouldn't have a good way of handling this. We could define a struct websites, but then there we would need to define in advance that we have Google, and that will hold a string value, and AWS, and that would hold a string value, and we wouldn't even be allowed to write Amazon Web Services like this. That would be an invalid struct key. So we would have a bunch of restrictions there, and we would simply use a feature to manage a collection of data that's not meant to be used for this purpose. You don't use structs to manage multiple values of the same kind with different keys, but instead you use structs to describe data entities in your programs. Something like a product or a user or a company or anything like that. And a map, on the other hand, is used if you have a collection of values which probably describe the same thing, though technically not necessarily, but then you can assign your own labels, your own keys, and use any kinds of values for those keys that make sense to you. So I hope I could make that clear what the difference between a struct and a map is, and why we have both, and why both solve different problems. In a nutshell, you can basically think of maps as arrays where you don't use indexes, but instead any labels of your choice.